Okay, good afternoon, class. I don't see anybody in the chat room, but I'm going to go ahead and get started. We're very close to the end of the course, and this week we're going to go over two more sections in Cycle 3. The first one is on writing linear equations and then actually solving them. Actually, no, I'm wrong. We're just going to write equations this time. We're writing equations of a straight line. And we're going to talk about slope-intercept form and how to write an equation in slope-intercept form, which is given right here, y equals mx plus b. And remember that we learned before on how to find the slope given 2 points. And let's take a look at some problems in this section. So write an equation for each line. So the first one we want to do is a line that passes through this point with this slope. Now notice the point they've given us is actually the y-intercept. So that makes our life a lot easier. And then they give us the slope, so we can just directly write this into the equation. Oh, okay, bear with me for a second. This does not have the right. Let's see if I can get the right slide up here. I'm sorry, I pulled up the wrong file. Hold on just a minute. Alright, just bear with me for a second because I've got the one that you're going to use as a handout and not the ones that has the worked out problems in it. So just bear with me while I search around for this. That's not it. Hold on just a second. It's again. There we go. And it should be this one here. I apologize. And hopefully this won't take too long to upload. Okay. So I apologize. The one we were looking at didn't have the worked out problems, and that's not very helpful for you as you're looking at the material with me. So let's just hope this won't take too long to upload. So let me... Alright, we'll just wait a minute. It's just going to take a couple of minutes, and again, I apologize I didn't have the proper material up here to get started. Okay, there we go. That was pretty quick. Alright, so this one has the answers in it, which will be helpful. Alright, so let's take a look at that first problem. Alright, so the first one I said they gave us the y-intercept, so that's going to be my b, and they gave us the slope, so I can just directly write this into the y equals mx plus b formula. Now the second example I have is the line passes through this point with this slope. So now I have to use what's called the point-slope formula. And to do that, what I do is I take y minus the y value in the point given equals m times x minus the x value given in the point that is on the line. So in other words, that's why it's called point, because you're using the point, the coordinates of the point given and the slope. And then go ahead and simplify. And so for this problem, I come up with an answer y equals 4x minus 12. And if I go ahead and substitute in the values given here, I'll find if I put in a 1 for 4 minus 12 gives me minus 8. And in fact, that point is on the line. And I notice also there's the slope of 4. Alright, how about this one? Now they've given me 2 points, and they want me to first, I'll have to find the slope, and we know how to do that. So we found the slope here is negative 1/2, and then I can use the point slope with either of the points given, my choice. So it doesn't matter, I went ahead and I used this point here. It would make no difference. You're going to get the same final resulting equation no matter which of the points you use. So again, I took y minus the y value for that point equals the slope, which I just found on the prior screen, times x minus the x coordinate for the point that I selected. And then I go ahead and simplify and end up in y equals mx plus b form. So again, I'm using the point slope formula. And again, we can check this and make sure that when I put this point in, if I put in negative 8 here, 1/2 of negative 8, negative 1/2 is 4, and 4 plus 2 is 6, and so it checks. And I can also check with the point that I used to create the equation. Okay, write an equation for the line, and now we've got ordered pairs of numbers, and we want to write the equation. So what do we do on this one? We're going to take a look at what's happening in the table here. So if I go here, the x is going up by 1, and the y is going down by 3, so we know that the slope is -3, and then here's my y-intercept right here, 0, 5, so I can go ahead and write the equation of that line. So a lot of different ways that the information can be given to you. So this is a horizontal line that passes through this particular point. The standard form of a horizontal line is going to be y equals, and it's going to be the y coordinate of that point, so y equals 5. The vertical line is going to have the general format of x equals, and in this case it's going to be x equals -3. So those are our two special case lines. All right, let's look at a connection here where we do a context problem. A printing company charges $275 setup for creating the template for a brochure, and then 29 cents per brochure. What's the fixed cost? The fixed cost means independent of the number of items produced. So in this case, the fixed cost is $275. The variable cost is the 29 cents per brochure. So now we can put that information together and write an equation called the cost equation. We're going to let y be cost and x be the number of brochures. So y is going to equal 275, the fixed cost, plus we call this the variable cost, which is 29 cents per times the number of copies. How much will it cost to print 200 brochures? So we're going to let x equal 200, and then go ahead and solve, and we find out $333. All right, let's change it around a little bit. Let's say we had $420 that we could use to print. How many brochures could we print? So now we're going to let y be 420 and then solve for x. So unfortunately it's overwritten here. I subtracted 275 from both sides and I got 145 equals 0.29x, and then I divide by 0.29 and I come up with 500 brochures can be printed for $420. Okay, the next section we're going to go over is exponential functions, which we've actually looked at earlier in the course, if you remember way back in the first cycle. Exponential change occurs in many contexts, including social networking, online marketing, also in things like the way bacteria grow, populations grow. So a website, a story, or a link can go viral and reach millions of people in a very short amount of time. And again, we explored this earlier in section 1.5, and now we're going to learn more about exponential functions in this section. And you've got a block in your book there on page 365 that goes over growth functions, decay functions, the general form of an exponential function, and we're going to look at that in a minute. So in that basic form, if you go back and take a look at that basic form here, which is going to be y equals a, which is going to be the initial amount, times b raised to the x power, where x is going to be a time parameter. So if b, remember that's the exponent, is equal to 1, then the equation simply becomes y equals a, which is a constant, and then that would just be a horizontal line and not an exponential curve. So we're always going to want b to be greater than 1. So multipliers that are whole numbers like 2 or 3 indicate values are doubling or tripling. They can also be interpreted as a percent. So for instance, a multiplier of 2, in other words, a base of 2, is the same thing as multiplying by 200% or increasing by 100%. If the multiplier is a decimal, then the rate of change is often interpreted as a percent. So suppose y is an exponential growth function, exponential function of x with an initial value of 7 and a 10% growth rate. Write the equation for y. Now the growth rate is going to have to be, we start at 100 and then we add, in this case, 10%. So this is where we had learned about the multipliers before. So that b in the equation, the initial is 7. The b here is going to be 1.1 because that represents a growth of 10% per time period of x, whatever x happens to be. Suppose y is an exponential function with an initial value of 7 and a 10% decay rate. So that means each time period we lose 10%. So we start at 100, we take away 10%, we end up at 90%. So here my multiplier is going to be 0.9. For each exponential function, state the following and then graph it. If it represents growth or decay, if it's increasing or decreasing, the starting value, the multiplier, the rate of change, and then 2 points on the graph. So let's take a look at some examples. So here is one example. So we've got y equals 8 times 1.1 to the x power. Okay, so this is growing, right, because this base here is greater than 1, increasing, and its starting initial value is 8. Multiplier is 1.1, so there's a 10% increase each time period, whatever x is. And what are some points on the graph? So if x is 0, y is going to be 1, right? 8 rather, because this part of the function would become a 1, and 1 times 8 is 8. And then what if x is a 1? So then we've got 8 times 1.1, or 8.8. So there's 2 points on the graph. And then let's take a look at what the graph would look like. So there's those 2 points we just found, 0, 8, and 1, 8.8, which is almost 9. All right, let's try another one. So y equals 5 times 1/2 to the x power. Okay, so this one's going to be what? A decreasing function, right? Because that b value, that base there, is less than 1. So this is decay. We started at a value of 5. The multiplier here is 1/2, or 0.5. The rate of change is a decrease each time period of 50%. And some points on the graph are going to be what? When x is 0, y is 5. And when x is 1, y is 5.5, or, I'm sorry, not 5.5, 5 halves. And then let's take a look at the graph. So here's the graph. There's 0, 5, and then there's the other point we said 1, 5 halves, which is right about there. All right, let's try an application. Candy Crush Saga is a popular app in which colored candies are matched. The app is free but requires purchases at a certain point to advance in the game. It also offers in-app purchases to progress faster. 1 year after its debut, it had been downloaded more than 500 million times. In a recent month, the app brought in $43 million in revenue after Apple and Google took 30% of the revenue. How much revenue did the app earn after paying Apple and Google? So basically what we want to say is 30% was taken away, so we want to know what 70% of $43 million. And that actually comes out to be, I'm sorry, they brought in, this was after, I apologize, this 43 million was after the 30% was taken away. So this 43 would represent what, 70% of the original. So the equation we could write, if we wanted to put the equation in here, it would be y equals, 43 equals 0.7 times x, and then if you solve for x, you'll come out with 61.4 million. If the app has been downloaded 500 million times already and gains 8 million new downloads each month, write a linear model of the form y equals mx plus b to represent the number of downloads. Let d be the number of downloads in millions and m in the months. So here we started out at 500 million, and then each month we add 8 million. So there's the linear equation that represents that. Now let's take a look at whether if it was exponentially. Let's say we started 500 million at the beginning, and then it was growing 2% each month. Write the exponential model, the y equals a times b to the x, to represent the number of downloads using the same variables. So in this case, we started at 500. It's increasing 2% each month, so the multiplier here is 1.02, and then it's raised to the m power, which is the number of months. Use each model to predict how long it would take to reach 1 billion. So with the linear model, if you go ahead and put in 1 billion for y and solve for how many months, it takes about 62.5 months, or a little bit more than 5 years. With the exponential model, here you're going to have to just guess in terms of what the multiplier or the exponent would be. It's going to take you a little bit less than 3 years. So you see what's happened by doing an exponential model there. We've cut the time in less than half. A little bit more than half of the amount of time. So when you need to write the equation of a line for which you're given two ordered pairs, neither of which is the y-intercept, you can use the slope to work backwards again and find the y-intercept. Once you know the slope and the y-intercept, you can write the equation. Similarly, when you are given a set of ordered pairs that show exponential change, you can use the rate of change to work backwards to the point if it's not known. If you have consecutive y values, you can divide them to find the multiplier. Otherwise, you can divide any two y values to get the multiplier, and that gets you from the first to the second. And then use the difference and the corresponding root to determine the multiplier. So for instance, if we want to construct a table for this one, these are some of the homework problems you're going to see. This is simply saying, okay, let's take some x values, substitute in here, and what do we get? So look at this. When x is 0, this becomes a 1, so y is going to be 4. When x is 1, this is going to become 4 over 3. And when x is 2, this is going to become 4 over 9. And then this one is an identifying the graph that goes with it. So let's take a look at the graphs. I know you can't make them bigger. In my math lab, you'll be able to click and make them larger. But the first point that has to be on the graph is 0, 4. And if I go ahead and look here, these are units of 4 along the y-axis. So that has a 0, 4 in it. This one does not, so I can eliminate B. Doesn't have that intercept there. This one is fine. I can probably use this one. This one I can eliminate. All right, so now let's take a look at the remaining ones and see what other points. Well, first of all, is this growing or is this decreasing? There's a hint here. Remember, this base is less than 1, so we know it's going to be an decay function. So the answer has to be graph A, because this is a decreasing graph. This one's an increasing graph. You're the first person to see a video, and you share the link with 9 friends. Each friend who sees the video shares it with 9 new people. Assume it takes 3 hours to share the video. Complete the following table to determine how many new viewers the video will have every 3 hours. Okay, so you're sending it to 3, and they're going to share it with each friend. You're the first person to see it. And then you're going to share it with 9. They're going to share it with 9. So how are we going to fill in the table? So we're going to go 9, and then each of these send it to 9. So 9 squared, 9 cubed, etc. Okay, and then that's the end of the material for 3.7 and 3.8. So hopefully this video will help you as you're working on your homework. And next week will be the last 2 sections of the course. So you should be working on your Cycle 3 material. And we'll finish up Cycle 3 next week, and then we'll be ready to get you set for the proctored final exam. So have a great week.